Um, Veronica and Kelsey, could I ask one of you to share your screen? And what we have is, for this presentation, Northwestern's Born Digital Repository Workflow. And our friends here, Veronica Lee Smith-Robinson and Kelsey O'Connell, are coming from Northwest University Libraries. And you're absolutely welcome to introduce yourself further. I got a little distracted with the intro, but we welcome anything you have to say, including this presentation.
Well, thank you so much. Hi, yeah, my name is Veronica Robinson, and I'm the Digital Asset Coordinator at Northwestern University Libraries. With me today is my colleague Kelsey O'Connell, who is our digital archivist. Today, we're going to give you an overview of our Born Digital workflows. And I say workflows plural because in our library, we actually have several different units that deal with library-owned Born Digital materials, both preserving and providing access to them. So the subtitle of this presentation is a workflow in progress because this is really our first or second iteration of like bringing these things together. And we're consistently tweaking things and updating processes to work more efficiently together and take into account new use cases and projects within our framework. All right. So a little bit of background here. Kelsey and I work with very similar digital materials, but at different scales and different levels of description and access. So she is part of the McCormick Library of Special Collections, which manages, and she manages both Born digital content from our other collections as well. I'm in digital products and data curation, and we support our digital preservation repository, both software and content. So these two units grew up from different roots and needs originally, but with Born digital content increasing and access needs evolving, we've grown together and now often work in tandem on projects and collections. So our work intersects, but Kelsey works with materials that are usually organized and described according to traditional archival practice. And I work with a combination of digitized and Born digital material and making those available in our web-based repository. And those are described in an item level. So while DPDC still mainly deals with digitized materials, we're starting to incorporate more Born digital content as well. All right. Oops. No, it's still alive. Can you all still see my slides?
Yes.
Okay, cool. Sorry, juggling some things here. All right. So because we have several units that work on the preservation of digital files, our library has developed an overarching digital preservation policy that guides all of us in our development and execution of these various processes. So this preservation policy outlines preservation's objectives, goals, including access and integrity, sustainability, and other dimensions. It defines levels of support for different kinds of digital materials under the policy, and describes sets of preservation actions like file format monitoring, persistent identifiers, metadata storage, based on those levels of support. So we practice a variety of digital preservation actions, but break them into different levels to help scale, sustain, and provide flexibility. We don't do every preservation action on every digital object in our collections. We use this approach to conduct ethical digital preservation while working within the limitations of available resources and technological capabilities. So the pyramid here is from our digital preservation policy and symbolizes how anything at a level 1 receives the maximum amount of preservation actions, while those categorized in 2 and 3 receive less preservation actions appropriately. I'm just going to try and drop this in the chat for you here. Oh,
I've already added the link.
Wonderful.
Yeah.
Thank you, Kelsey. Perfect. All right. So here we have table which itemizes which level receives which preservation action. So many of our Born digital items are categorized at level 3. But as you can see here, those still receive a robust set of preservation actions, including auditing, redundancy, security, comprehensive storage, and virus checking. So since we can't do everything on everything, we do as much as we can on as much as we can. All right, so here I'm going to hand it off to Kelsey who can take you through an overview of her Born Digital archival workflow. After that, I'm going to take back the reins and tell you a bit about our repository workflow. And finally, we'll tell you how we've woven these two sets of procedures together to create a consistent and efficient process for new materials entering the collections that are ultimately bound for repository access.
Thanks, Veronica. So we'll go to the next slide. The first step in the Born Digital archival workflow is acquiring files and transferring them off their original media carriers. These can come from a variety of sources like accessions, a current processing project, or even the backlog. And the media can be obsolete or current, so I have to use a variety of software and hardware for acquiring data depending on those items. And the primary purpose of acquisition is to begin digital preservation. And we cannot rely on the original media carriers to permanently store and preserve the data. So moving it to a more stable location reduces those risks of harm, corruption, or data loss. And in the interest of time, I'm not going to go into those specific tools, but we do have them attached to these slides for when we share everything out later. Next slide. And the next step is appraisal, which is the vital part of the workflow after acquisition. It may be an easy thing to overlook as we have so much access to storage, but I find a bit more work at the beginning to appraise is going to lead more responsible and intentional custody of our collections. Next slide. We live in a culture in which it is easy and affordable to save as much data as we seemingly want. It can be much simpler to migrate a large amount of data rather than risking bit rot by relying on original media carriers. Broadly speaking, though, emerging trends in archival appraisal argues that we should spend the time to evaluate the content before sending it off to preservation storage. I practice a reciprocal appraisal, so I measure any technical feasibilities of the data itself against traditional archival theory. Technical appraisal and content appraisal must inform each other in a cyclical fashion, and with digital records, there just isn't one rule that fits everything. For archival content appraisal, I collaborate with curators and subject selectors to evaluate the intrinsic value of the content. Technical appraisal, as an extension of content appraisal, evaluates the feasibility of systems and infrastructure to account for complex data. It helps analyze file formats, file makeup, file systems, operating system storage, and other technical considerations that need assessment in order to make decisions about preservation and access. Making decisions about technical appraisal helps inform content appraisal, vice versa. So for example, just because something is complex, large, or varied in the data and will be more time consuming to preserve and process doesn't mean we won't preserve the collection depending on its content appraisal and cultural heritage value. I've written a lot of documentation on this. Just reach out to me if you want more. It's not going to be detailed in these slides. So next slide, please. Depending on the outcome of those appraisal assessments, I may conduct other actions on the data or simply begin moving it to preservation storage. However, the appraisal may reveal needs for optional actions such as deduplication, weeding, conducting PII scans or personally identifiable information scans, metadata extraction. Those are all options for preparing data for permanent storage. And the outcome of effective appraisal is to conduct only those optional actions that are most necessary to move data to preservation. Just as it isn't ideal to save everything, we don't want to conduct every process on every bit of data. Once data is moved into preservation storage, it is known as the AIP Archival Information Package APE location. And this is the copy of the data that we keep permanently and then make derivatives from. Any original local copies of the originally transferred data is deleted once the APE is in place. Next slide. This is a quick overview of things that happen once we go into processing. So the ingested files stay in preservation storage until they are recalled for archival processing. And I export a copy of the APE, and those files are saved to local workstations as the derivative. From there, that derivative becomes our first DIP, or dissemination information package, meaning that it's the first iteration of what the process collection will be and what patrons will ultimately access. At this stage, more appraisal may be conducted to see if we need to do some of those other actions again or to begin with. So we might employ digital forensics or even file format normalizations. After any of these actions are completed, the files are arranged and described according to archival practice, and defining aid is created. We finalize the DIP by transferring a copy of the file to their permanent storage location. By assessing the collection's rights information and feasibilities, we make other decisions on appropriate access methods, such as will it be available publicly online in a closed virtual reading room, or do we need to keep things on-prem only in a reading room on site? Next slide. So this diagram is meant to represent how the data from these archival workflows move through our different storage locations. And the center of the diagram is a block representing the Born Digital Lab. And that's where we have customized computer workstations for accessioning and processing Born Digital archival materials. Each of these machines includes the RAID 1 config, and so they have a little bit of backup. The processing workstations are used for appraisal activities, digital forensics, digital preservation, and archival processing. On the left of the diagram is the SIP, or Submission Information Package location, where the initial accessioning tasks were conducted. This is the temporary storage of a NAS server, but it does have one level of redundancy to aid in any potential recovery efforts. Once those files have been through our accessioning workflow, they are moved off the space into the APE storage, and that's depicted below the lab in that icon of a cloud, which represents the permanent preservation storage for both processed and unprocessed tapes. We use AWS S3 object storage for that as our primary vendor. And then off to the right is of the diagram, there are sort of two locations depicted for our DIP locations, which is the derivative copies of collections that we are ready to share with patrons for access. So the primary copy is kept on a separate NAS server, separate from the SIP, that is NAS server, and that's accessible to all special collections staff. Another permanent copy does live alongside the APES and AWS. Patrons don't have direct access to this location. Instead, we still copy data from this to local workstations or online or however it is requested. And lastly, we have sort of this secondary tertiary storage location, which is depicted diagonally off to the bottom right of this diagram. And in some instances, we are ingesting the preservation and access copies of only processed collections right now, to Meadow. That's our institutional repository tool. Because this is a robust preservation and access platform, we do not keep separate copies in AWS or NAS servers. This is a tool that is managed by Veronica's department, and she's going to talk about it now.
On mute. Okay. All right. So our Born Digital repository workflow lives alongside, Kelsey's workflow here. So the repository houses digitized content for the most part, but I'm also in charge of ingesting previously digitized or natively electronic content that's been requested for access specifically in the repository. Sometimes this is content that's housed on external carriers like CDs and DVDs, or content that's received in a digital format that is meant for repository access. For example, the Herskovits Library, which is within our the Northwestern University Libraries, acquired a portfolio of artwork from an Egyptian artist, Ganzir. It included posters, prints, zines, and also a USB flash drive of digital files. This was an already processed collection, and I was tasked with extracting the files from the drive and making them available to a researcher in our repository. We support access to the library's digital resources through several products, but I'm going to address our preservation repository, Meadow, which publishes works to our digital collections library online. Digital Collections is our website that provides all user access to digitized assets from NUL's distinctive collections. And Meadow is our digital asset management tool, which is like the NUL staff back end of the digital collections website. We also have our public digital collections API, which allows public access to our digital collections published data in a programmatic way. We also support Arch, which is our institutional self-deposit repository for research, and AVR for our streaming course reserves. Got a little bit wonky, but that's okay. You can still sort of read it. Okay. All right, so what is Meadow exactly? So Meadow is our homegrown repository system that we built in-house, as we are fortunate enough to have our own team of developers. All of our code is open source and publicly available via GitHub. We use AWS and open source tooling and S3 storage and a Postgres database for the system. It's what we like to call our preservation first repository system, because when we conceived of it, we built it to ingest files right after digitization, performing all those preservation actions and securing the files. And then we add metadata to those items, either individually or using bulk actions. And so those files are preserved while we're adding the descriptive metadata to it. you can see in the diagram here, we used to have what we call the danger zone, which is when files would reside on servers waiting to have their full metadata created, and then they would be ingested with their metadata. But we flipped that script so that we could try and get those files into safe storage and then work on the metadata. It also has the added advantage of library staff having easy access to the files once they're in Meadow. So before we even complete the descriptive metadata, our librarians can access those files and share them with researchers before they're published to our site if they need to. Right. And in order to ingest files into our preservation repository, we need to take a few different steps. We start with the similar accessioning tasks like Kelsey's. We receive the files or we migrate them off a carrier. Oftentimes we use Kelsey's hardware because she's very generous to let us use it. And then we put them into our working storage server. From there, we do a lot of the same tasks such as file and file name normalization, weeding, deduplication, if necessary, things like that. After those tasks are complete, we do an analysis of the files for questions of copyright and visibility and access in the system, if that is information hasn't been already established by the collection previously. We coordinate with curators, our copyright librarian, and other content experts on these questions. And then we also work with these content experts and our existing finding aids or catalog records to structure the files in the repository. We catalog the materials in Meadow on an item level. We group individual file sets into what we call works. So a work is an intellectual unit. It can have one or more file sets associated with it. So for example, a book with 300 individual pages, each one a file, or just a photograph that's one file and has no others. And both of those are a work. So in this way, we need to kind of think about how we're going to logically group these and like what is the object really. So we need to look at the files, talk to the content experts, read the finding aid, and come up with how best to sort of display this as an intellectual unit to researchers. So all of this informs the file inventory data we need in order to ingest the content into the repository. So then we move into creating our inventory and ingest sheet. This is a file level inventory in a CSV format. As part of our preservation first angle, we have only 7 required metadata fields in order to Meadow to successfully add an item to preservation storage. So we need to flatten out any sort of nested order that the file has, any sort of like file structure, because we're ingesting these as individual items, not like hierarchical. So we retain file path information, that kind of thing, usually as series information. We indicate what the work type is, image, audio, video, the work accession number that groups files together as a work, the file accession number, that's a unique identifier, the file name, of course, and a label and description, very brief, and the file role. If it's an access copy, a preservation copy, we also can include supplementary files and things like that. So we take those files, we upload them to an S3 bucket via FTP, and then we go into Meadow and upload this CSV ingest sheet into the application. And then based on the CSV, Meadow can then run a series of, it can go retrieve the files from the S3 bucket and perform all of these preservation actions, and then create work records in the database for us to access. So here's a diagram of that basic sort of repository workflow. We have our files on the working storage server while we prepare the ingest and inventory sheet. Then we upload those files to the S3 bucket and kick off an ingestion process, uploading the CSV to the Meadow UI. So Meadow uses the inventory or the ingest sheet to identify the appropriate files in the S3 bucket. It creates database records, records checksums, extracts and records embedded metadata, kicks off a transcoding process if it's needed, copies files to preservation storage, creates a IIIF ready pyramid TIFF for access use and derivative generation, and several other activities. So for preservation purposes, our files are copied over to an additional preservation location, and that storage location is then replicated into a second storage region for security. In addition, the files being ingested into Meadow, they're ingested, and then we also take the working copies of those files and upload them into a separate Deep Glacier AWS account that's managed by NULIT infrastructure. Okay, so here's a little video. I don't know, yeah, I won't probably play the whole thing, but this is just so you can see when it's a web-based application. So our staff can then can log in and access. And we have like projects, which are usually digitization projects. This is the Sun Ra collection. We've got bulk actions that you can do to adjust the metadata. And if you go into a work page, you can see the metadata. We've got shareable links that we can share out with people. Our IIIF manifest descriptive metadata here and administrative metadata, like project metadata. And then here are our access files and preservation. It's preservation information display, essentially. We can go look and see what file set actions were performed on it. We also have a preservation dashboard here that runs checks every evening on all of the locations and files, just kind of touches and makes sure they're all where they say they should be and that sort of thing. So we can go resolve any errors that we throw at night and see if like preservation file didn't copy correctly yesterday or something like that. Advance. Oh, it's going to do that thing. Okay. Where it doesn't advance because you're playing a video. Okay, there we go. So how does this all come together? The what happens when we're acquiring a new collection of digital material that's intended for the repository to be ingested into Meadow for access via DC and the API, but it's coming through Kelsey, we have to kind of figure out how to mush our two workflows together appropriately. So the last couple of years, we've had like an uptick in these kinds of collections. For instance, we acquired photographer Peter Moore's archive, which included digital files and analog files. So they had to go through Kelsey's accessioning process and then come to us for access. And more recently, we acquired the Black Experience at Northwestern University Oral Histories collection. It's a project of one of our librarians to collect audio and video oral history interviews with Black students, staff, and faculty. It's an ongoing project, so we're receiving groups of interviews and associated files in batches as they're completed. So here you can see just sort of an example of an accession record that Kelsey has created, and then the output on our side, which is the interviews in the digital collections library. All right, so in these instances, the materials need to go through both Kelsey's accessioning workflow and mine. So in order to make the process efficient and consistent and make sure that the curators and librarians know how we're handling the files and who to talk to at any given point in the process, we actually sat down in a series of meetings and figured out where each step needed to go in order and make sure that we had a consistent process for this. We have a much more detailed process that we worked out, but I figured we didn't need to have all the little like who to talk to at any given point thing here. So I don't have that. So the main thing for us has been communication between the two of us to make sure that we're both on the same page. If circumstances change during the process, as they often do, that we may, timelines may change, deadlines may change, and we might need to break projects into batches or things like that. But we did our best to try and streamline the process so that we could minimize the number of handoffs and file transfers back and forth. Being added, so as we're working on them, we're continuously adding to them. So I'm going to take you through this little thing. So first we go through Kelsey's archival accessioning, where she is transferring the files and consulting with the curator, getting these things through our cataloging processes, doing digital forensics practices, and just generally accessioning, all that stuff. This is usually the point where we are notified of this project so that we at least know it's coming down the pike. And from there, she'll pass the files off to us, and then I will go through the repository accessioning process. Again, consultation with the curators as needed for information, assessing the files, and creating that inventory. Then I will ingest them into Meadow. They receive their preservation actions. We put the admin data on them and then descriptive metadata and publish them to DC. But really, as soon as we've gotten them into Meadow, we can usually confirm that they're all there, double check everything, and then we can do project completion and closeout, where Kelsey can delete the SIP from her working storage. We move our working files to the Glacier backup, and we usually notify the curator and let them know all their stuff's ready. So thank you very much. This is still all a work in progress. So we're just this is the first iteration, and I think that as new projects arise, things are going to get continuously built upon and iterated on. And as part of the slides, we do have some supplementary things as well, like our repository architecture and some tools and things like that.
Wonderful, thank you.